Hello students, welcome back to our online classes from Albion Public School situated at Gola Bazar, Gorakhpur. So students, this is your subject teacher of science and today I am here with a explanation of chapter number 9, that is force, work and energy. So without wasting your time, take out your textbook and your stationery items along with you. Let's begin the class. So students, the name of the chapter is force, work and energy. So here I am going to summarize this chapter. When we push a cart, it moves away from us. If we pull it towards us, it moves towards us. What else can force do besides making things move? It can stop a moving object. It can change the direction of a moving object. It can also change the shape of an object states of matter. So my dear students, in our daily life, we often use our muscles to pull or push things. We pick up a glass of milk to get it to our mouth. We push an object to move in a particular, or we can say that in specific direction. We come to realize that either a pull or push is required to move an object. So force is a push or pull on an object. Now students, let's discuss about the kinds of forces. Magnetic force, muscular force, gravitational force, electrostatic force, and the last one is friction, known as contact force. So let's discuss about kinds of forces in brief. So students, force exerted because of the magnets is called magnetic force, and muscular force is caused by the action of muscles in our body. It is a muscular force that enables us to perform all activities involving movement or bending of our body. Next is gravitational force. So students, gravity acts on every object on the earth. This is why when we throw anything up, it comes down. That is the reason the planets revolve around the sun and satellites revolve around the planets. Now, did you know? Sir Isaac Newton discovered gravity when he saw a falling apple. He called this force gravity, from Latin word gravitas, meaning heaviness. So students, gravity is the force present in any object that pulls other object towards itself. Now next is electrostatic force. Students, when you rub a balloon on your hair and your hair stick to the balloon, that's because of these charges. When you rub the balloons, it picks up some of the charges from your hair. The charges on the balloon and the charges on your hair start to attract each other, and they pull the balloons towards your hair. But here's the trick. Charges that are the same, like two positive or two negatives, don't really like being close to each other. They try to push away. So electrostatic force is this invisible pull or push that charges can have on each other. Now let's come to the next one, that is friction. So the force which acts on it to slow it down is called the force of friction. It is also an opposing or stopping force. So students, friction is also known as Opposing or stopping force. Friction is when two surfaces come in contact. Its direction is always opposite to the direction of the motion. The frictional force ultimately stops a moving body. For example, place a toy car on both a rough surface like concrete and a smooth surface like glass. You will notice that the toy car moves more quickly on the smooth surface. Reason? This is because the force of friction is less on a smooth surface. Let's take another example. When we kick a ball to make it roll on the ground, it starts moving, but eventually it stops. The reason behind this? It stops because the ground pushes back on the ball, slowing it down and eventually stopping it. A student's friction majorly depend on the surface of the material. It has nothing to do with the weight of the material, and there is some amount of heat produced during friction. Any lubrication reduces friction. For example, oiling a cycle reduces friction, and adding water on any surface reduces friction. Air also exhibits friction. Here, few examples of rough surface and smooth surface are given. Now let's move on to the next topic, that is work. If force is applied to a body and it begins to move and goes to some distance, it is said that work is done. So when we use force to move things, we do work. So students, you can say that work is done if an object changes its position due to the force applied on it. If there is no change in the object's position despite the application of force, then no work is considered to be done. Pushing a chair is easy, but pushing a cupboard or full of books is difficult. We have to use more force to move the cupboard. So we do more work in the moving cupboard than in moving the chair. But in case the cupboard doesn't move, then no work is done. So students, I hope you understood all the concept very clearly by the help of this video. So in our next video, we will discuss about our next topic, that is energy and forms of energy. Thank you, students.